So if you're writing this down, there's a missing name. And so the compressor is going to compress the refrigerant. It's going to draw the refrigerant in from the vapor line. And it's going to jam that refrigerant into the discharge line. Now, the discharge line is kind of small.
Good morning.
Good afternoon.
Yeah.
Just turned it off, sorry. Jam it into the discharge line. And so now our molecules of refrigerant are being asked to share a very small space. And so, therefore, of course, the forces go up, the pressure goes up, and they rub together a lot, which, of course, is the measurement of temperature, right? The temperature goes up. And so the gas pressure goes up and the gas temperature goes up, sky high, here in the discharge line. And so in the old days, they used to call that the hot gas line, because it's very hot. That line gets very hot. 175, maybe 200 degrees. It's very hot. If you touch it, it's like, ouch. And so if you accidentally, you'll know it, because it'll make you jump. So very high temperature there. That way, if it's hot outside, it's still cooler than the hot gas line. And so you can cool down your refrigerant from that very high temperature, even though it's 100 degrees outside. And so if we can get our gas temperature down to 100 degrees, would be great, but it doesn't get that far. It cools off in the condenser to a point somewhere just over ambient temperature. I don't think I need any of this stuff, right?
Nope.
Just over ambient temperature. And so, it's going to fall. It needs to move. We'll start in the middle. Here's our compressor. There it is right there. And the discharge line, or what used to be known as the hot gas line, goes into the condensing coils. And there they are. And so we're coming into this discharge line. I can't spell it. That's probably an H right there, and an A. Like that. Yeah. Discharge. And so, discharge line. Hey, good morning.
Good morning. Good
It's probably like 175 degrees right there. And vapor. It's vapor only. Vapor. And it's also under high pressure. So high pressure. That's what's going on in the discharge line. Hot, high pressure vapor. Hey, what would you call here's your line, right? What would you call a vapor? This is your vapor state. Here is your latent heat, right? You guys studied this line yet?
Yes.
Latent heat, that's your latent heat. And then we have liquid over here. Right? What would you call a vapor that is above that point right there? Anybody remember what that point right there is?
Sensible heat.
Saturation, yes, saturation.
Saturation for it.
That's your point of saturation. And any heat added above the point of saturation to a vapor is called superheat, right?
Superheat.
Superheat. And so, it's very superheated right here. So you got your hot, high pressure, superheated vapor entering the discharge line. The compressor is, and now the molecules are banging together hard, and that friction causes temperature to go sky high. Now, with some outdoor air blowing up through here, we can cool that hot gas down. And so, what's up? 95 degrees, the machine runs perfect, factory numbers. And so, hopefully, it's going to be close to perfect all the time. So, because we have aluminum in contact with the air, and the aluminum is pressed onto the copper tubing, and the copper tubing on the inside is touching the refrigerant, there's going to be a difference in the temperature of the air and the temperature of the refrigerant. aluminum and copper isn't perfect, and so the air temperature doesn't get all the way in. And so there's going to be a slight difference. And that difference is going to be somewhere right around the ambient air temperature, which in this case is 95 degrees, plus about 30 degrees for the copper and aluminum, 30 degrees, to get through that copper and aluminum and actually take the energy, BTU, out of the refrigerant. Also, at this point, from here to there, it's a straight line. That I didn't draw it very straight. It's a straight line. This temperature here is, of course, the boiling point. That's the boiling point. Boiling point. That's the point of saturation. 100% vapor at the boiling temperature is the definition for saturation. There it is, 100% liquid at the boiling point, and so there it is, the boiling point. And that temperature is established by the pressure. Temperature and pressure are fixed. And so whatever you do with your pressure, that changes the temperature. So, water boils at
212.
212. Here. Anywhere else, it doesn't boil at 212. If you were a school kid in Denver, Colorado, water boils right in your textbook, 209 degrees. They don't know anything about 212, and we don't know anything about 209, but definitely, because they're higher from sea level, there's less atmosphere pushing down on them, so their pressure in their kitchen is a lot lower than us. And so because of the change in pressure, they have a change in boiling temperature. Now, we can change the pressure using this compressor enormously, from really high to really low pressures. And so we can make big changes in boiling temperatures. But yeah, any change in pressure changes boiling temperature. Where's the sign in?